Let's move on to number 39. We'll be talking about Dalton's law of partial pressures here. You'll notice that as we go through these problems, you're going to see gas collected over water. Realize that those are still Dalton's law of partial pressure problems. All right, three of the primary components of air are carbon dioxide, nitrogen, and oxygen. And a sample containing a mixture of only these gases at exactly 1 atmospheric pressure. The partial pressures of carbon dioxide and nitrogen are as given. What is the partial pressure of oxygen? Okay, we're exactly 1 atmosphere pressure. Now, before you go down and write 1 ATM, notice that these two pressures are related in torr. So I'm going to use the torr value. Now, the Dalton's law of partial pressures is total pressure, or atmospheric pressure, is equal to the pressure of, in this case, it would be CO2 plus the pressure of N2 plus the pressure of O2. Now we're being asked to calculate the partial pressure of oxygen, which would be right here. So in order to do that, I have to get it by itself on this side of the equal sign. So I'll subtract these values from both sides. So I'll end up with pressure of oxygen is equal to total pressure minus pressure of CO2 minus the pressure of N2. And using the numbers that I've been given already, that's 760 torr minus 0.285 torr, and then minus 593.52 torr. I'm going to close to the end of the page. And I'm ready to calculate. So 700 minus 0.285 minus 593.525. And I get this value here. And notice I'm doing addition and subtraction in the last portion of this question. So what I need to do is I need to look at how many decimal places are past the decimal for these values that I'm using. And see 1, 2, 3 places past the decimal, 1, 2, 3 places past the decimal. And so my answer is going to have 3 places past the decimal. If you're wondering why I'm not looking at this 760 and seeing that it has no places past the decimal, remember that this is a definition. Up in the question it says exactly 1 atmosphere of pressure. 760 is exactly 1 atmosphere of pressure and therefore does not limit the number of significant figures that I can use. And so I'm going to report 166.190 torr as my final answer.